Okay, thank you all for making it again today. I know we've got the last day and two sessions, so we're opening up with Auth and Search. I'm joined today, of course, by Elbert, but also Chris and Kate. I'll let you introduce yourselves.
Hi, I'm Cade. I'll be presenting authentication.
And Chris over here, I'll be doing the search portion of today.
All right, Kate, well, I think we're starting with you, right?
Yep. All right. Hello, everyone. This session will focus on authentication and authorization with Broadleaf Authentication Services. Like I said, my name is Cade Ray, and I've been with Broadleaf for about 6 years. In this session, we're going to begin with a quick overview of some general principles of identity and access management, as well as a brief introduction to OAuth. After that, we'll look at permissions and roles, see how they're used. Then we'll look at the policy framework. We'll look at some configuration examples and discuss some tasks that you might need to do during implementation. And then finally, we'll see some of the security configuration available in the admin. There's a lot of information to cover, so I'm going to try to go pretty quick, especially here at the beginning. The first section is about some general IAM and OAuth concepts. We'll start with some terminology. IAM stands for Identity and Access Management. The access is being managed for resources, in this context, the API endpoints and the data they return. The core of IAM is identity. Anyone who wants to access a resource should be identified. Authentication is the verification of that digital identity, and authorization is the process of determining what resources a user can access. So to summarize, authentication determines who a user is, and authorization determines what they can do. Here's an overview of the OAuth 2 authorization grant flow. A quick summary of the process is that the client in green wants to access a resource in red. The resource requires authorization, so the client interacts with the authorization server in gray to ultimately get an access token. The client presents the access token to the resource and the call is successful. One of the primary benefits of this flow is that the resource server does not have to handle user credentials. A resource server simply needs to verify and use the access token. This also allows users to grant specific access to specific resources. Here's a detailed diagram of the process that our storefront application uses to authenticate and
Sorry for
access.
interrupting. Can you back just to previous screen? Just okay. The flow is you're taking the token, then okay. You're making the process through 4 times or what? I didn't know the flow here, the authentication about the token.
Yeah, so the flow here, I summarized the auth server part, but essentially, you'll talk to authorization, you'll see that it's not authorized, and then you'll redirect to a login page on the authentication service. That will return an identity token, and then you'll exchange that identity token for an access token. And then once you have the access token, you can access the resource.
Sorry for this question, but is there a difference between identity token and access token?
Yes. The identity token it can be long-lived, and all it proves is that you are who you say you are. And the access tokens are very short-lived. And the access tokens are the ones that say exactly what you can do. And we'll look a little bit deeper in the access token in a couple slides.
Okay, this is related to the admin. Is that right? Not the normal customer or maybe our customer. Is that right?
This is a simplified OAuth 2 authorization grant flow. So this applies to both the admin and the storefront, but it's a simplified diagram of how each uses.
Okay.
Okay. And so, like I said, this is the simplified diagram. This diagram is the detailed diagram of the process the storefront uses. And the storefront uses a flow called silent authorization, so that the user doesn't have to be distracted as much with some other things that are sometimes in an OAuth flow. But I wasn't going into detail on this. This slide was mostly to point you to our Dev Central, where that does go into detail on this flow and some of the other topics. And we just looked at the authorization code grant, which goes back and forth. We saw with the authorization server to like login and stuff. But for service-to-service requests, we use client credential grant, which each service is configured with a client ID and a client secret for the other services that they need to communicate with. And the client credential grant can only be used for trusted sources, since the client ID and client secret are all that's necessary to be authorized. And so client ID and client secret is kind of like a username and password that's hard-coded, which is why this can only be used for trusted sources.
Do you have a predefined client ID, or I can creating different client ID?
Yes, the client IDs they're predefined in that they come out of the box named, but you could rename them if you needed to rename the client ID. And this example is from our card ops service.
Each service having own client ID.
Yes.
Perfect. Okay.
And in the admin, which we'll see at the end of the presentation, you can also specify like exactly what scopes and permissions are allowed, like that this client could access. And we'll see an example of that at the end. Okay. So with either of those grant flows that we just looked at, authorization code grant or client credential grant, you get an access token. And these access tokens are essentially JSON objects that have been encoded and cryptographically signed for authenticity. The resource server enforces access control based on the data here in the token. If you look at this example token at the top.
Sorry to interrupt you here, just to understand correctly before you continue. This is the request, is that right? Or this is the response?
This is a response from. Yeah, so I'll go back to this simplified diagram. Oops. So when we get the access token back from the auth server toward the bottom, when we get the access token back, that's the example that I was showing. And then we're going to use this access token to access the resources. So upon successful authorization, you'll get an access token. And we'll look at some of these sections here. The top section in white just has basic info about the token itself, such as the client ID, scope, and expiration. Section 2 in blue, we see identity claims about who the user is, such as their name and ID. The third section in red has claims about the user's context, such as which application they're using. And the last section in green lists the specific permissions granted by this token. And these permissions will correspond to the scope of the token. And so this section in green is kind of the most important part about this access token, because it does indicate to the resource server exactly what this user has authorized the client to do. In this case, it's a product token in the product scope. So this user is able to read, update, delete, and create products.
And maybe put point special attention. This is called a JOT, and it's a pretty standard thing. So it's not exclusive to us.
Yes, excellent point. Yeah, and that JWT is typically pronounced JOT. And like we mentioned before, this is a pretty short-lived token, so that if anybody got a hold of this token, they could use it. So there's always an expiration date and a max time to live. Okay, so now we're going to look at roles and permissions. We saw in the access token that the access token contained a list of permissions, so we're going to take a deeper look into those. Permissions are the basic unit of access control in authentication services. The strings in the green box, read customer, update product in all order. Those are all examples of permissions that represent different levels of access. The permission string is a concatenation of the operation type and the permission root. Valid operation types that you can see there: create, read, update, delete, and we also support all. And permission roots are typically an entity name or action that's protected. And permissions are typically very granular. And I'll actually show you in the admin real quick. I'll show you a list of. So here is the admin. We see on the left side, there's a security section. And we can just look at some permissions here. Impersonation, customer service representative, reading inventory, all inventory, etc. They're really granular, and they're designed to restrict access to really particular pieces. And we'll look at this a little bit later at the end of the presentation as well. Scope is an OAuth concept. Scopes are sets of related permissions, and they're essentially the permission roots that we just talked about in the last slide. For instance, product relates to read product, create product, update product, and delete product. During authorization, a client requests access to a set of scopes, and in the resulting token, the services grant permission for that scope that the user is authorized for. And for a concrete example, we'll think about how admins and customers both need to access products in the catalog. Admins have full CRUD access, while customers should only have read access. In both cases, both front-end apps will just request the product scope, and authentication services will grant the user's permissions that correspond to that requested scope. And so for admin, they'll get that list of permissions that we saw on the token. Down here, the read, update, delete, create, they'll get a list of those. But if the customer requests product scope, they'll only get read product. Roles are sets of permissions that make it easy to assign permissions to users. Since permissions are so granular, we don't typically assign them directly to users. It's a lot easier to make a role that has a whole set of permissions. And so, for example, in the admin, there might be a role for merchandisers and a role for customer service agents, and they would each have their own sets of permissions. And customers are assigned a default customer role with appropriate permissions to shop in the store. And here in this table, we see some examples of some of the roles with some of the permissions that they contain. Okay, so up to this point, we've seen that authenticating and authorizing yields an access token. That access token specifies the permissions that are granted to the client. Now, how do resource services use this token to enforce access? The primary method is an @policy annotation. So app policy is a broadleaf method annotation that helps enforce security by preventing access to resources from the wrong context. It's typically defined on API endpoints or repository methods. And so whether the user can see or mutate the resource are determined by the context of the operation, the permission of the user, and the ownership of the resource. And a concrete example is that one thing app policy can do is validate that a user has appropriate permissions to execute the method. So here's an example of the app policy annotation. This example is not from a real endpoint. It's just for demonstration purposes. And most usages will only need to declare a few of these properties. We've got all the properties here on display though. The first three properties at the top, they configure permission validation. So we see permission roots, operation types, and permission matching strategy. The permission roots indicate what kinds of permissions are needed. The operation types is what you can do. And the permission matching strategy indicates if you need any of the permission roots or all of them. And so just these first three lines, they configure this policy annotation to validate that the user executing this method has either update customer or update customer profile permissions. And then parameters 4 through 7 configure ownership validation. Broadleaf has an interface called owned, where owned entities have the ID of their owner as a field. And some examples are like orders and customer addresses that they are owned by a customer. And so when we specify the owner identity type in line 4, that triggers the ownership checks. The owner identifier in line 5, that indicates which claim on the access token is the owner ID, in this case, customer ID. The owner identifier param indicates which of these method parameters should align with that owner ID. So the first method parameter here, marked number 6, it is string customer ID. And so in the app policy parameter, when you specify that owner identifier param, it indicates that this first method parameter should match the owner identifier. It's kind of convoluted, but I think when you see the actual code there, it makes sense that customer ID is the owner, and so we're going to match that against the access token. The last in the list, the param parameter, indicates which of the method parameters is an owned entity. So in this case, this second parameter is a customer object, and customer is owned by customer. And so we validate that entity is owned by the user that owns the access token. And these things are to prevent authorized users from updating objects that they don't own. You don't want one user to update somebody else's order or somebody else's customer address or something like that. So that's what the ownership checks validate. And one other detail to app policy is this context info parameter to update customer. This method is set up with an update context operation. And so if any time during the execution of this method, if, for instance, a create or a delete is attempted, then an exception would be thrown, because we're saying that when we're updating customer, only updates are allowed. So here are 3 examples of some real examples from the framework. You can see that the app policy only has 1 or 2 fields defined. So the top 2 are from API endpoints, and the bottom one is from a repository method. And you can see they specify permission roots or perhaps identity types, operation types, but it's generally unnecessary to it's generally unnecessary to have like all 7 parameters.
So you meaning I don't need to add all fields, is that right?
Yeah, that's correct. And that's going to be completely dependent on, whatever that method is doing and checking. Um, and I think by far the most common is like this top example where we're just saying the policy is saying we need product permission routes, and the context operation says we need update permissions, and so that equates to, for permissions, you could have update product or all product, and I think that's probably the most common
Yeah,
usage.
and when I define, for example, here a product, when I said all product, this mean I can update also the product like you define the policy here.
Yes. Yeah, all would encompass the other 4 types.
Okay, can you please back to the previous slide?
Yes.
I don't know what you meaning about the owner identifier and owner identifier parameter, and also the parameter at the end.
Right. Yeah. So those all relate to the ownership of this entity. So in this case, this update customer method, the second parameter takes in a customer object, and so we need to verify that that customer object is the customer that is logged in. So our access token has a customer ID that indicates, who logged in, who put in their username and password, and we're going to verify that this customer object being updated is owned by that person who logged in, so that you can't just submit a completely different customer and have the database update that. Because by permissions, like, if you have update customer permission for your own profile, that's good for this. You need to be able to update the customer for this method, but you don't need to update every customer. You just need to update your own customer. And so that's where the ownership checks come in.
Sorry, is the customer ID, it will be in the token?
Yes, the customer ID. Yeah, let's flip back and look at the token and we can see that. So in this particular example on the screen is an admin token. So
Okay.
a customer token in the blue section where we've got user ID and admin user ID. For a customer token, we would have user ID and customer ID.
Okay. It will be the naming of in the token, it will be customer underscore ID instead of user underscore ID. Is that right?
Yes. Yes.
Okay.
Yeah. Yes. So let's see. Probably would have been helpful to have these two right next to each other. But yeah, so customer underscore ID, that is in red on line 5. That indicates that on the access token, we're looking for a claim of customer underscore ID. And that's going to drive the ownership checks. And just one call out here, customer underscore ID is the default for owner identifier. So that's one reason that you typically don't need to specify that parameter, is because it defaults to customer underscore ID.
Okay.
And in similar fashion, line 6 here says that the owner identifier parameter says that parameter 0 is the owner identifier. And so this string customer ID, that needs to match the customer underscore ID claim from the token. And we see that in the get mapping /customer/customer ID. And again, this is to prevent, you could be authorized with your own permissions, but if you just put somebody else's customer ID in there to try to update their customer, policy is going to catch that and say, the customer ID that you're trying to update is not you. You have to be the owner of that.
Okay.
All right. So this slide summarizes the factors the app policy looks at. It looks at the execution context with that context operation that's declared in the method parameters. It looks at user permissions, and it also looks at ownership. You also see on the right side of this slide, I've got some classes called out for some further reading on that if you want to really dig down into policy. And these next few slides go into a lot of details on what exactly is validated. I'm not going to speak to each of them, but you'll get a copy of this deck. And so if you wanted to dive into these slides for more details, you're welcome to. This slide talks about permission validation, how exactly it's done. We briefly covered a bit of this. We've also got a slide about ownership validation. We talked about this a pretty good amount just now. One detail that I did mention here at the bottom highlighted is that if you're returning an owned entity, like from a read endpoint, we're also going to validate that the current user owns that entity that's being returned. So like if you're doing a read customer, you're not reading somebody else's customer. And then context mutability is also validated. And that just means, you know, is the user allowed to change this entity, or is it just allowed to read it? And like I said, there's a lot of details in those last few slides in the slide and in the slide comments. So if you're really interested in that stuff, you can dive in there. So now we're going to look at some usage and extensions that you might need to do with the Auth service. By default, authentication services will act as both an identity provider and an authorization server. One thing that is possible to do is to use an alternative identity provider. So instead of using the built-in username and password page, you can just defer to a different provider for the authentication step. And then any like scopes or roles that are granted by the external provider, you can copy those to the broadleaf token, and then you can validate on those with that policy and other related details. And the diagram is the same diagram that we saw earlier. Earlier, we concentrated on the gray box as a whole, but when you break out the identity provider, you basically get the yellow and the blue separated, and the yellow handles the authentication, whereas the blue handles authorization. I heard you were looking into using Keycloak to manage authentication. I briefly looked into it, and it looks like they provide a library that includes an authentication provider. Basic configuration would simply involve registering that provider with Spring's Authentication Manager, and then creating an authentication strategy delegate to map the Keycloak authentication details to broadleaf details. And the flow would look like during request processing, Spring Security would attempt to authenticate the request with Keycloak. If successful, Broadleaf's default session authentication strategy is called, and that strategy defers to authentication strategy delegates to map their particular authentications to broadleaf details. And so, for instance, if you had multiple identity providers available, then these delegates would, check to see what actually got authenticated, and then there's custom logic for each provider to map their details to the broadleaf user details. There's more links here at the bottom of the slide and also in the slide notes. Another thing that you might need to do is add a whole new service to the ecosystem. Securing new resources is pretty easy. You simply add the Broadleaf OAuth 2 resource security library as a dependency, and then the new service will be able to verify access tokens and use the policy features. When taking your app to production, there's a number of things to consider. There's a link here to an article in our Dev Central about going to production. But one of the more important things to call out is that is about generating new keys for signing and validating your JOT tokens. It's really important to generate new keys because you do not want to use sample keys in production. There's also another number of other features of broadleaf auth services. For instance, impersonation is a powerful feature that allows a customer support representative to use the store on behalf of a customer. Another example from this list is embedded login. If you have a native app that needs to collect the user credentials, you can enable embedded login, and that won't redirect to the login page for universal login. And also, if you have a native app or some web app that needs refresh tokens, you can also enable those. At the bottom of the slide, there's links to documentation, examples, and more resources in Dev Central. And now we're going to take a brief look in the admin just to see some of the screens and configuration that are available there. I'll switch over to my admin view. All right, and here's the permission list that we just saw. You see all these big list of permissions. And if we look at roles, we see a little bit easier to digest list here. So we can see that so like a base user can just do workflow things. A full access has so many permissions. They can do everything. We also have a partial access that just has a bunch of read permissions. And since and you can see here that you could take away permissions or you could add permissions as necessary. So you can manage this through the admin. And then this role customer user is the default role that storefront customers get. And you can see they can read products, and they have all on their customer payments, and they have all in their profile. They have like read on menus and read on categories. So these are just permissions that make sense for browsing the store. We can also look at our list of users. The user section is admin users. If we were looking at customers, we would look in the commerce section, and I would need to be in a specific application. But the users are admin users, and we can go in here and look, and we can see that we assign them roles. This is a vendor admin. We could also assign individual permissions to users, but like I said, that's typically not necessary, and you'll typically have those permissions defined in a role. Also show off the authorization servers. Configuration here determines how you authorize. So if we look at the server that controls the admin, we can see you can declare timeouts and failed login attempts. Lots of different things there. You could give some default roles or permissions to anybody who logs in here. And you can also see the clients that are authorized on the server. So there's the admin client, and we see configuration here with their OAuth settings, such as like redirect URLs, and you can see grant types. So the admin allows authorization code and refresh token. And if we look at, for instance, the storefront, Heat Clinic, and each of our storefronts has a different authorization server in this case. But we can see that Heat Clinic, anybody who shows up there gets the customer user role, and their client is only set up to do an authorization code. If you needed a refresh token, you could add that in there. And then also we'll look at the services. So for service-to-service communication, it goes off these authorization settings, and you can see these different services: cart ops, order ops, inventory. They all have their own client ID and their own client secret, and they authorize with the services authorization server. Okay, so that was a lot of information there. That is all the material I had prepared. Were there any questions before I hand it over to Chris? Okay.
Yeah, maybe one more thing to add to this is that most often a lot of this is going to accompany a code change, so you generally aren't going to, add a new permission here or something like that. You'll add
Yes.
a
Yeah,
new
that's
piece of code that uses a permission, and then you'll add that, during your deployment.
right. That's a great point, Chris. You can add permissions here. You can add roles and affect that, but the catch there is if you add a permission here, you haven't updated the code to like protect anything with that permission. So when you actually update the code to check for that permission, that's also a good time to just add that new permission via a liquid-based SQL update and also update your roles. So that's a good point, Chris. Okay, I'm going to stop sharing and hand it over to Chris.
All right.
And just a quick time check. I've let Chad know for offers promos that will likely be running late. Do you know about how long this section should go, Chris?
My goal is 30 minutes.
Okay,
There's a lot to cover here, so hopefully,
yeah.
Hopefully,
I'll let Chad know that we'll start offers and promos at 8:15 or 8:30.
Okay.
Thanks.
All right. So, yeah, my name is Chris Schneider. Today, I'm going to be talking to you about our broadleaf search. Before I get into this, really, this is mainly our search service. There could be a whole other presentation on Solar itself. I'll be talking a little bit about Solar, but mainly want to get into search itself and the indexing process and kind of cover any things that you might need to know there about how to consume the service and if you need to do any extensions to do those kind of things. So to start with, we're going to do kind of just an overview of the different pieces involved with that make search work. I'm going to touch on the front-end API. I'm going to go into field definitions, a very important topic. Field definitions actually define what is indexed and how it's indexed and searched. And then we're going to talk about the indexer service and the search service specifically. So getting into the search overview, there are 3 components to broadleaf search, and that's going to be our indexer service. That is actually kind of responsible for building out the input documents that go into our search engine, which in this case is Solar. So that service will retrieve data from different services. In our case, we've got products, customers, and orders that we index. And then it transforms it into something that is actually consumable by the search engine. And that's called indexing. And then we have both real-time or incremental and full indexing support. I'll go into more of those in a later slide. The search service, pretty simply, is just responsible for actually performing queries against the search engine. And then our search engine is being Solar, ingests the documents and handles any queries that come from the search service. So we'll get into our front-end API, which is, I'm actually going to go look into the docs for us here because there's really only 2 APIs here. You've got search products and search suggestions. So I'm going to look at our docs here real quick. So search products, very specific, right? We are actually doing searches on products. And And you can see the very basic part of a very basic query here using search products on the front end. You can just pass in a query. Optionally as well, we can pass in something called filters, which are which can filter down some search results. These would often be used as facets. A weird thing about this API is it can actually return two different things, and I'll get into the one of these in a later slide. But you've got a search response, which is going to contain a list of products as a potential result, and then you've also got a search redirect response. So you do need to account for both of these. If you get a search redirect response, you need to redirect to a new page. So we'll look at this search response real quick, and this will make a little bit more sense when we get to field definitions. But as for the front end, we've got things called facets. You'll get those back in your search response, and a facet is the thing different. A facet is basically a potential filter. So you might get back, hey, these are the different brands that I have that I can filter by, or the the different prices, various things, product properties that somebody would commonly want to filter on. You've got sorts. So the search engine will tell you what you can sort by as well. And you can display those to the user. We've got another feature called spell check. So there are two potential options for spell check. You can get back this corrected query, which means that the search engine would automatically auto-corrected your query if it found a typo. Or, and this is disabled by default, you can turn this on. In the case that you get 0 search results and the search engine finds, and search service finds that, there was a different query that you could have ran that would have got results, it can automatically run that query and send you back that response in a single API request. Or there's the spell check result, which includes any potential words that you may have misspelled and suggestions for those words that could have so for instance, if you misspelled, let's say you were searching for Apple and you put APPE, the search engine might come back and say, hey, did you mean APPLE? So, and that's a thing that you can display to the user and have them say, click a link, right, and redo the query with the spell checked result.
Hey, Chris, it looks like we have a question.
Yeah.
Yeah, is this for product, or this is you're talking about generic how the solar is working? You just can go up, please. Again. Here you're talking about in general the responses, or this is for specific for the session product?
These are using our Commerce SDK. So these are the responses that you get when you're on the front end wanting to interact with the search service. Does that answer your question?
This is, you mean if I need to search in anything for product, customer, anything else?
Yes.
Okay.
Yeah, and most likely you're not going to need to do anything with customer or order. Those are on only backend functions. So, and those are already configured. But yes, they use the same APIs. Yeah. Search suggestions. So let's go back here and look at suggestions. Now notice that the suggestions is more generic. It doesn't say search product suggestions. It's just search suggestions. And you'll see as I go through this, we also call it type ahead. They're kind of the same. We kind of use those terms interchangeably, type ahead and suggestions. This is going to return various data, and I have another section on type ahead specifically. But one of the things that you'll get back, and in fact, real quick, we can look at the website. That might make it more clear. So if I type in something here, you'll see that I get back, this is my suggestions API responses. So the suggestions API can be customized to return back specific products that match a query. So we've got a product section here. and I'll reference this again later. And we can return categories with facets on them. It says, we've got 6 matches in this category, 6 in this, 2 in this. And then we have the suggestions themselves, the autocomplete suggestions as well. These come back by default. These other 2 up here are completely configurable. So we've configured this to return products, but you can configure it in other ways as well. And if we look at this, you can see it is a record with a string and unknown, because this is a completely customizable API response. And this, I'll go into this again in a later slide on how this is configured and what you'll get back. And it should make more sense when we get there. Any questions before I move on from this? Okay. So now we're going to get into field definitions. This is a pretty complex topic, so I'm going to try to address it as best as I can. So this is a domain that resides in our search service, and it defines a field to be indexed that can be searched, optionally searched, and how it is searched. And we'll look at an example of a field definition in the admin as well. And it defines lots of various attributes on a field. So field type, is it a string? Is it a numeric data type, Boolean, etc.? Is it facetable? Is it multi-valued? So, some values are going to be single valued, like a product name. Some are going to be multi-valued, like, what categories is that product in? It can be in multiple categories. And is it searchable, and various other things. So we're going to log into the admin here and look at a field definition. Field definitions are tenant level. So if we look under the search drop down here in fields, we can see all of the field definitions that are declared. We can see some for product, some for customer, order, etc. Let's look at product name as one. So you can see there's a lot going on this page. We've got a label. This is just a something for the UI, so this only displays, this is only relevant in the admin. We've got an indexable type, which can be product, order, customer. This means that this name field only applies to the product type. Does this field contain a list of values? This is it a multi-valued field, and a product only has a single name? An abbreviation, which means when we get this back, this kind of determines how the value is indexed, and also what the name of the value is when we get it back from a search response, which we just have name. So you'll get a product back in your search response, and this name value is going to be mapped to name in the product response. We've got a property path. This is actually a JSON path. So all of these are, let me actually find a better example for that. We'll look at category IDs. So if you're familiar with JSON path, this should look sort of familiar to you. We exclude the $ period in the front. This says grab all of the categories, and then all of the items in that array, and then their ID, and we're going to map them to a category IDs field to be indexed. There is a feature here where we can combine multiple fields into a single indexed value. It's not commonly used, but it is available if you find yourself needing to do that. In that case, you would have multiple property paths, and you would specify how those fields are going to be concatenated together. We actually don't even use this out of box, but it is there if you need to do it. I'll come back to variants in a minute. And this is a pretty big. There's a whole other screen underneath this. Here is where we would define faceting, and I don't know if I showed faceting, so let me do a little search here, and I can show a facet. So on the left side here, and this is, you've seen this on lots of websites, I'm sure, you have what we call facets, and I can filter down my search results based on category, brand, price, different attributes, and in this case we have a discount type. And if I click these, it filters these down. These are going to be returned from the search engine, so you would display them here on the left side. This is all programmatically created. And those, whether or not something is facetable or not, we select that with this Boolean here, yes or no. And you can see we can define a field type, a label, and what order that's going to be displayed in, as well as, can you select multiple of these? So I might want to, you see these are defined as multiple select, which again is something your UI is going to have to handle. Whether or not it's ranged. So ranged makes sense, in the case of like price or perhaps other values, maybe, I don't know, storage or that kind of thing. And then whether or not a facet is ruled. So this is something that you can add as well. If you only want a facet to show on a certain category, you can select that from here. So getting into variants, I'm going to do my best here. I'm going to actually add some documentation on this to these slides before we give them to you guys. When you're defining a field, you need to define how it is indexed and what fields it's going to be indexed under. So we've got values for single values and multi-values. So you remember we defined this as a multi-valued field. So it's going to use string multi. We've got all of our primitive, numerical types here. We've got different string types. And all of these string types affect how this value is going to be searched. So string, lowercase string, text partial, text phonetic. I'm actually going to make some adjustments to these slides to kind of cover these, and we need to add this to our documentation because there's a lot here. And all of these are going to affect how this is indexed and how it's going to be able to be searched. Here's the spell check feature I talked about. If you want a field to be spell checked, it needs to have this field assigned. And you can select multiples, right? So I don't have to have just strings. I can have text, which is a more loosely typed or loosely matching field. So it will be more forgiving on things like case and support synonyms, various things like that. If a type is, we have email, we have text phonetic, which supports name matching. You should only use this on customer names. So we've got Boolean, email, as I discussed, date, location, currency, monetary amount. All of these can be configured on a field definition, and all of these are going to affect your search results. So again, I'll add a little bit more documentation on each one of these and what these do before we hand these slides over to you, and that should make it more clear on how do you use these fields. You'll notice we have an include in results as well. You really only want to have one of these fields included in results. That keeps, so you don't need the category IDs multiple times. So you flag one of your fields if you need it in your search results to come back in your search request. Come back from your search request. So we've got a field that can be marked as sorted or not. It doesn't make sense to sort by category ID. So we have that. We don't have that set here, but you can add a sort as well and a label. You can mark a field as searchable. It doesn't make sense to search on a category ID, right? But we do want that in the index for filtering purposes. So let me go back again to the name. And you can see we have different ways of searching this, as well as boost values. So what this says, there's 3 different query types that are supported: word, phrase, and exact phrase. Word means a single word match. So if this was a Apple iPhone and somebody searched for Apple, that would say, okay, this matches the single word Apple, or the Apple iPhone matches the single word Apple. So that would be a match. And we're going to match against the string type. We have phrase, which is a loose matching that includes phrase slop. In fact, I have a little link to docs here. Oops. That better explains this. So word query type should be used when you know that a field is a single string or single word matching is desired on a term with spaces. Phrase supports searching on a phrase, and you have slot matching. So Apple, for instance, I'll go into slot matching actually in a later slide. And then we've got phrase exact when you want no phrase slop. And phrase slop means that we can match on terms that are not close together. I'll actually give an example of that later, and that would make sense. And then we can actually configure boosting as well. So when we want to boost, say I have a product Apple iPhone and I have an exact match, then I'm going to boost this on Apple iPhone. I'm going to boost it by 10. So you can tweak your search results here using boosts for exact matches. I know this is really complex, and it's a contention point for me to kind of just improve our documentation on this, and perhaps even improve the UI somewhat. We have internationalization. So is this field translatable? This means that we have, remember we're talking about product name here. Product name is a translatable field. So this needs to be marked as translatable. If this is a translatable field, then those values will be, the translated fields will also be indexed, and you can search on the translated field. All of this is translatable as well. So again, we have a sort here. You know, if we wanted to add a different language, all of these labels on this field definition are translatable, as well as the facet labels. Any questions? I know there's a lot on this screen, and it's very complex.
Yeah, I have 2 questions here, Christopher.
Yes.
The first one is, can I add, if I added new fields in the product table or in the product, by the way, can I add it in the Solar? This is the first question. And the second question, how to sync between the product and add it to Apache Solar, how this mechanism is done.
I'm going to get into that. So the short answer is yes, you can do that. If it may be, depending on how that field is going to be used, you might just add a new field definition and say, you know, what is the property path to that? Think of the product domain, right? Like it has a field called name in it. If it's just a simple string field, you would just add a new field here, and that would automatically get indexed. If you've got something more complex, you can do a customization, which I think I'm going to get into in the next slide here. So yeah, either you add a new field or you add a customization in the search that will index that field.
How to map it to the name in the database, in which fields here in the front end, in the admin?
So think of a product. I wonder if I can actually let's go into here. So if you were to add a new field in Broadleaf, you're going to get back a. Do I have the product in here? Oh, this is a bunch of stuff. So we have a product, right? And the product is, if you add a new product and a new property to a product in Broadleaf, it's going to come back in your regular product response. So let's say I wanted to map currency, right? I would just add a new field definition that with a property path pointing at that field. And then that's going to come back every time when the indexer queries the catalog, that field's just going to come back as a new field on the product. So you're naturally going to get that back in your indexer when you make the call out to get new products. And you just need a new field definition that is going to put that new field into your index. So if you make a product extension, you're going to get that value back automatically through Broadleaf.
Perfect.
You just need to tell indexer to consume.
And I can filter by it. Is that not? I can filter by this field.
You can filter by this field, yes, if you configure a facet for it, yes.
Okay. And for the second question, how to sync between the, I think, correct me if I'm wrong, you are syncing from the database to the Apache Solr. Is that correct?
The database has no impact here. So what search makes a call out to the catalog service. In fact, let me go forward a couple slides here. So this is an example of the index flow. All the indexer does is call the catalog service and get the products back. So if you add a new field to a product, that's going to be available to the indexer. You just need to tell the indexer that it needs to put it in the search engine. Does that answer your question?
No, sorry, I didn't use Solr, by the way. It's something like the caching or what the mechanism of Solr. I mean, if I'm trying to search for a specific item or specific product, are you getting from the Solr or you are trying to get it from the database?
Oh, okay. That's going to come from Solr, yes. That comes, so you would interact with the search service if you're searching for a product, and the search service would return that product.
That means for every product that you added if you are creating a new product, it will be inserted in Solr and also in database at the same time.
It will first be put into the database and then put into Solr.
Yeah. My question here: how to add it to the Solr? Who is responsible to add it in the Solr?
So actually, that's my next slide here. So that is the process of incremental reindexing, right? So the indexer will listen for change events. So if a new product is created, that's a product change event. The indexer will then listen and say, oh, a new product has been created. It calls out to the catalog service and then pulls that new product and puts it into the index. So every time a product changes, a product change event is created. And that could be a product edit, a new product, anything related to a product. The indexer is going to listen to that for that event and then index that new product.
Yeah, if we recall, kind of to the first one of our first sessions, I had a diagram around sort of the service anatomy of every microservice, and basically one of the examples that is relevant here is if you make a change in the admin to a product, it's going to persist that product change to inside the catalog service, and that's going to be persisted to the data store that's tied to that catalog service. That persistence event is going to bubble up and make its way to the message broker. And that persistence event is going to be listened to the other microservices that need to know about it and care about it. And one of the the other microservices that cares about it is exactly what Chris is talking about right now, which is the indexer microservice, which is going to do that reindex for that product.
Okay, good. So I think the Kafka will be also on this flow.
That's absolutely correct. Kafka is the messaging broker, or whatever messaging broker you have on the back end is the plumbing in place that communicates that message.
Okay, cool.
Yeah, that's actually the next slide. So yeah, if the indexer will retrieve data from other services, catalog, customer, order. It then processes that data using a series of document preprocessors and document contributors. I'll talk a bit about these. And then it does support incremental reindexing, which is what we were just talking about. So if you make a product change event gets fired, the indexer listens for that event and handles that, either reindexes the product if it's a product change or just creates a new one. Other examples of that, customer and order as well, is the same thing. So if a new customer is registered, indexer listens to that. If a customer edits themselves, or an order is submitted, or an order is modified or fulfilled, the indexer listens to all of these events and then does a index of that change. You can also trigger a full reindex, which will reindex everything at once. So all of your products can be reindexed, or all of your customers or orders. If somehow you end up in a bad state and your search is messed up, oftentimes that can just be fixed by a full reindex. Other times, if you were to make, say, some serious changes, adding a new field, for instance, that might require a full reindex. But in general, an incremental will handle, your day-to-day operations, whereas, full reindex, that kind of depends on your system when and what your circumstances are when you might need to do a full reindex.
Yeah, is all services inserted in Apache Solar, or you have a specific services?
Specific services. It's just these three: product, customer, and order, that are going to have their data indexed in search.
Yeah, catalog is meaning a product. Is that right?
I'm sorry, I missed the first part. Say again.
Catalog meaning here you are.
Yes. Yeah. Let's. Yeah. Catalog products live in catalog. So
Okay,
yes, the catalog service. This is a kind of a view of the indexing flow. So we've got the indexer. If you were to trigger a full reindex, this is the flow that's going to happen. The indexer says, give me all of the product IDs from the catalog. It then splits those product IDs into batches, and then retrieves the products. Each product batch is going to go through the document preprocessor flow. And then the document preprocessor flow allows you to process the entire batch at once. So if you need to, say, retrieve some data from another service or transform that data for some reason, you would do that in the document preprocessor flow. That allows you to operate on the entire batch at once for efficiency there. And then each individual product is going to go into the document contributor flow. And ultimately, out of that flow, you're going to have Solar documents, which are going to be consumed into Solar. This is the same flow for incremental as well. You're just going to cut out this this part here, right? It's just your product ID batch is just going to be one product ID, but the same flow applies. Most often, if you want to do a customization, it's generally a single. You're going to operate on a single product at a time. Say add a new field, so like a document contributor. As an example, here's an example of a very basic document contributor that we have out of box. This is the active dates contributor. I think we don't want to add. We want to add the active start and end date to a product outside of the regular flow to make sure it's always there. And you can see it's a very simple. So we just get the product start date, the product end date, and then we add those fields to the Solar document. And that's all that this does. This is a very common implementation. Generally, your customizations in this are going to be something like this. You just implement the document builder contributor, register that as a Spring Bean, and that automatically gets put into the flow. So you don't have to modify any existing broadleaf code most of the time here, unless there's some kind of bug or special customization you want. You would simply add a custom contributor or document preprocessor to the indexer flow. All right, moving on. We've got the search service. So this guy will actually query the search engine. It supports the traditional search and type ahead search, as we talked about. And then very similar to the indexer service, it uses a series of query contributors and response decorators. So if you want to customize this flow, you would implement one of these. I have a little diagram here in our docs kind of showing this. So you've got your search request coming in from your user, a series of query contributors will convert this into a format usable by the search engine. And then you've got the response coming back, and you can implement a response decorator, which can modify that response that then gets sent back to the caller. So in order to customize these, you would implement either a query contributor or response decorator. More often than not, you're not going to do a response decorator, but you can. It's generally a query contributor that you're going to implement. And here's an example of here's on the search side, I just showed that active date contributor. This is on the indexer side. This is the active date contributor on the search side, which if we look at this, we're going to filter for only products that are active. So we've got a filter date. We'll say it's just instant now, right? And we're going to add that. We're going to create a start date filter and an end date filter and just add them to the Solar query. And you can see all we did was extend this abstract Solar query contributor and implement these 3 methods. A thing to point out here is there are potentially different filters for the type ahead versus a regular search. If you want your contributor to work on type ahead, you need to return true here. You need to tell it what does it apply to. This one only applies to the product type. And then optionally, there is also the type ahead preprocessor and postprocessor. These only apply to type ahead. So if you need special logic for type ahead, you implement one of these. And that's generally, this is all that you're going to need to know if you need to customize search is implementations of these classes, these four interfaces, I should say. Moving on. Oop. Let's see. We've got a couple more slides here. So type ahead. Also suggestions allows the auto completion of the search queries. I showed that as an example earlier. That is configurable via the admin, though most often any type ahead changes are going to come along with code changes, so you're probably going to do these as part of your regular deployment cycle. You'll get the suggestions by default, search suggestions, but you can also return more complex data. As we saw earlier, we can have suggested products and categories. And, here's an example query. So we have to provide, remember, this is a generic, kind of more generic API. We tell it that we want to use a specific configuration of product type ahead, and then a specific query of green. So to look at this in the admin again, I know we're running low on time, so I'm going to try to go through this pretty quickly. We have a config name, product type ahead. So we told in our API, we're going to use that product type ahead config, and then we're going to pass in a query that tells it to use this configuration in the admin. We can see that it applies to products. We could select other type ahead types as well here. We have a suggestion limit, which is 10. That means we can get up to 10 suggested terms back. A phrase slop, and we have a highlight prepend and append. And that shows here, if I do a search of hot, you can see that has been highlighted, the hot part of it. That just means it's just more of a UI styling thing here. So you can have that, the admin do that for you. And then we have a phrase slop, as I talked about earlier. That allows matching of terms that are 2 terms away. So it's kind of hard to explain that in words, but let's use this as an example, this bull snort hot sauce bundle. So if I type in that, the phrase slop of 2 means that we'll match terms that are up to 2 terms away. So this is bull, and then snort is term 0, hot is term 1, and sauce is term 2. So if I type in bull sauce, you can see that's 2 terms away. So that still matches. I can type in bull hot, that will match as well. But once I type in bull bundle, we know we get no results. That's because the phrase slop is 2 and bundle is 3 terms away. So bull 0, 1, 2, and that's why this guy matches. So you can, adjust this, make it larger or smaller if you want to make your response more generic or more precise. You can adjust these values. We've got in the highlight field. So this is the actual field that gets searched upon whenever we do a type ahead search. We only have the text type ahead field that we're searching on, and we're only searching on name. So this field allows for the partial matching. So, if I type in SNO, you can see we get it matched snort. So this field allows for very loose matching to support type ahead. And then, as we talked about earlier, we get those other results back. The additional, if you want additional data back, you would define it in the suggestion fields here. So if you think about all the things that we need to display this product section, we need a image asset, we need a link, we need a price and a name. And if we look in this product suggestions section here, we can see that we get all that data back that's necessary for showing that on that section in our search results. So we've got a name, a description. We're actually not using that description, but we've got a URI that points to the product URI, a primary asset, and a price and a currency. So that all will allow us to display, additional things in our type ahead response if we want them. And we have a limit of, and as well as, we want to limit this to 10 products. We can also configure it as faceted, which will give us the counts like we see here, but it doesn't make sense to have counts on our product results, so we don't have that configured as faceted. So all this is configurable. So this is why the type ahead result is pretty generic, is you can configure any type of fields to be returned here, depending on what you want to show on your type ahead results. Any questions on this before we move on? All right. We're already out of time here. Apologies for that, guys. There was a lot to go over here. I know
Yeah, we packed two big topics into 1 hour, so appreciate it. I think that was good. If there are additional questions, we can always follow up over offline as well. I know that we are going to need another full hour for the offers and promotions. Hopefully on the Vodafone side, you guys can run over by a half hour. But what we'll do is end this video, and then we'll start the next meeting. They are separate links. So.
Okay, could we postpone for next Monday, Parag?
We can keep going if you all are okay. If you all would prefer to postpone to Monday, I just need to see if the other trainer is available.
Okay, we will be available next Monday, so postpone, please.
Okay. I don't know if we will be available at that time, but I will get back with you over email and let you know for sure. I'll shift.
Okay, well, Monday, Thursday. Okay, no problem.
Monday or Tuesday.
Yes.
Okay. All right. Great. Well, thank you all for staying with us late. I know it's also on the edge of your weekend, so we really appreciate your time.
Okay. Thank you.
Thank you.
Thank you.